Welcome to today's video. In this video, we'll be covering IUPAC Nomenclature, and we'll be going through examples to see the differences between different namings for different compounds. Let's start with the basic hydrocarbon. Okay, one carbon atom with 4 hydrogens on it. This is a hydrocarbon, which means it consists of carbon and hydrogen only, and it is called alkane, so it's called methane. If there were 2 carbon atoms, it's another hydrocarbon, it's an alkane, so they're only single bonds, no double bonds. This is called ethane. You'll see the difference between these two in terms of the name is the prefix, meth and eth. This was mentioned in our previous videos, but because they are important for IUPAC naming, we need to know that if you have 1 carbon atom, your prefix will be meth. If you have 2, your prefix will be eth. If you have 3, your prefix will be prop. If you have 4, your prefix will be but. If you have 5, your prefix will be pent. If you have 6, the prefix will be hex. If you have 7, your prefix will be hept. And if you have 8, your prefix will be oct. We'll stop there for now, because usually the questions that they ask you don't get that complicated, meaning not more than 8 carbon atoms mostly. But you can look into it just to keep your mind sharp, just to make sure that you're on top of things. So if we had a hydrocarbon compound with 1, 2, 3, 4, 5 carbon atoms, let's say it's an alkane, so there are only single bonds between the carbon atoms, and it's a hydrocarbon, so there are only hydrogen atoms connected to the carbon atoms. This compound, since it has 1, 2, 3, 4, 5 carbon atoms, has the prefix pent. And because there are only single bonds and it's hydrocarbon, it's a pentane. So what would happen if we had a double bond instead of a single bond? Well, a carbon atom can only have 4 bonds connected to it, so we'd lose some of the hydrogen bonds that are connected to the carbon atoms. So we'd have 1, 2, 3, 4 bonds for this carbon atom, and 1, 2, 3, 4 bonds for that carbon atom, and the rest still the same. The only changes are on the carbon atoms that are affected by the double bond. This changes the name. Pent remains the same because there are still 1, 2, 3, 4, 5 carbon atoms, but since there is a double bond, it's no longer an alkane, it's an alkene. So the name or the suffix changes to "ene" because it is now an alkene. If we had a triple bond instead of a double bond, again, each carbon atom should have 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds, and the suffix changes to "-ine" because it's now an alkyne. That covers the hydrocarbons. If you're not familiar with this, check our previous videos. That goes into more details on naming for hydrocarbons. Let's go back to the alkane, pentane. Let's say our molecule looked a bit something like this. This part here has a lot of carbon atoms, and that might get confusing. So what chemists like to do is they like to represent this in a more condensed way, and we'll be using that to simplify our structures from this point onwards. So this can be represented by writing down all the carbon atoms and just writing the number of hydrogen atoms connected to the carbon atoms. So we can have H3 because there's 3 hydrogen atoms on that one, H because there's only 1 hydrogen atom on that one. This one should have 3, so that should have been H3, and so forth. So this is H2, this one has 1, this one has 3, sorry, this one has 2, this one has 3, that one has 3, I'll add it later, and then we connect all the carbons together. So that's the condensed structure. So if you have something like this, do not freak out. What you need to do is identify the longest carbon chain. So what that means is the chain of carbon atoms that are connected to each other that form the largest number without going back. So let's start off here and say 1, 2, 3. I can't go back. So definitely there are more than 3 carbons connected to each other if we look at this chain here. 1, 2, 3, 4, 5. Our initial carbon chain. But then what happens if we decide not to go all the way straight there, but go 1, 2, 3, 4 and come down here? We have 1, 2, 3, 4, 5, 6 carbons. So now as you can see, the longest carbon chain is actually 6 carbon atoms, no longer 5 in this compound. Which means that this can be represented as just a side chain of the carbon atoms. And this is also just a side chain of the carbon atoms. It's not part of the main parent chain. So another way of looking at this is like this. See 1, 2, 3, 4, 5, 6 carbon chains with 1 side chain on the second and another side chain on the 1, 2, 3, 4 on the fourth. Just gonna write it at the bottom because there's something up there. So the reason why we have 6 now is because this long carbon chain can be represented like this. And that means that this side chain is this part here, and that side chain is this part here. So the parent chain can be bent, it can also be straight. You just need to identify the longest carbon chain. So if you have something like this, it's important to number the carbons based on identifying the lowest numbers for the substituents in this case. So what does that mean? Let's start naming the carbons of the parent chain from here. So we have 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. We would have a substituent on 2 and a substituent on 4. If we numbered the chain from here, we'd have 1, 2, 3, 4, 5, and 6, which means we'd have a substituent on 3 and another substituent on 5 instead of 2 and 4. See, these two have lower numbers than these two. So you pick this instead of the higher numbers to decide how you're going to number the parent chain or the carbons on the parent chain. So the right way to number this compound is from here to here. So 1, 2, 3, 4, 5. That means our substituents are on 2 and 4. So what do we have here? We have an alkane, which means our suffix is going to be ane, which need to be indicated on the name so we can understand what this compound looks like just by the name. So we have our substituent on 2 and 4. They are both the same. So we have, in our naming, we'll have 2 and 4 to indicate the positions of the substituents. And because they are 2 and they are the same, we're going to put di to indicate that they are 2. And then we'll note what type of substituent they are. This is a methyl substituent. And then we'll note the parent chain, which is the hexane. So the full name is 2,4-dimethyl because there are 2 substituents. They are methyl groups, and their parent chain is a hexane. So 2,4-dimethyl hexane. So what if we had something like this? CH3 2. Instead of one carbon atom there, we added another one. And yeah, that carbon has 2 hydrogen atoms and this one has 3 hydrogen atoms. What we have now is an interesting case. We could go 1, 2, 3, 4, 5, 6 carbon chains, but if we went straight 1, 2, 3, 4, 5, 6, we'd still have 6 carbon chains. So now we have an interesting case. Our parent carbon chain could be like this, or it could be like this. In both cases, we realize that our substituent at this point will always be on the 4th carbon. So We have a carbon with 2 hydrogen atoms and a carbon with 3 hydrogen atoms, and the same thing here. A carbon with 2 hydrogen atoms and a carbon with 3 hydrogen atoms. So whether you choose this line here as your parent chain, or whether you choose this bent one as your parent chain, it will still give you the same answer. Let's stick to the bent one. So we'll have 5 and 6. We'll have our substituents still on 2 and 4. But we have another interesting substituent here, which has 2 carbon atoms. Now, following the same table that we introduced with naming, the substituents follow the same rules. Branch-chained alkanes are called alkyls, and they are named as follows. So if you have an alkyl with 1 carbon, it's methyl, like we had in the previous example. 2 carbon atoms is ethyl, 3 is propyl, 4 is butyl, and I think you see the trend here, so I'll just fill the rest in. So in this case, we have 1 methyl group and 1 ethyl group. Now with alkyls, we write them in alphabetical order, and since ethyl comes before methyl, E comes before M, alphabetically we have 4 ethyl, 2 methyl, and then we have our parent chain, which is the hexane. So 4 ethyl, 2 methyl hexane. That'll be it for part 1 of IUPAC Nomenclature. I think that'll be enough for our brains for now, and then we'll move in the next videos to haloalkanes, alcohols, carboxylic acids, esters, and aldehydes.